Oh, it's astrophysics time! The best option in IB physics. And clearly, if you are here, it's because your teacher is incredibly awesome and has tricked you into choosing astrophysics, which is a no-brainer. In this lesson, which I could go on and on, but limited to a short one, we're going to talk about these stellar clusters, how they're different than constellations, light years, how big they are, and also how big our galaxy is, and we'll look at how these stars move over the course of a night and how the constellations shift. This is a pretty self-explanatory term, the light year. It is how far light travels in 1 year. If you mess that up, you might be removed from IB physics. But what that value is, also you want to write down, 10 to the 15th meters. Clearly, that's giant. You have to know the difference between a cluster of stars and a constellation of stars. They're very different. A stellar cluster, drag the definition on here, is a bunch of stars packed together and they're all of a similar age. We know they're of the same age because they all formed from the same cloud. Now, here's a picture of what this would be. Is a globular cluster, and they are more dense in the center. They may have up to millions of stars in them, and they might only be a few hundred light years across, which compared to the hundreds of thousands of light years across our galaxies, that's pretty small. Our sun is not in a stellar cluster. The other type that you could have, is what's called an open cluster, where there's not a density, but they are still quite close. There's not nearly as many as in a globular. This is my favorite. This is the Pleiades, which the Japanese name for Pleiades is Subaru, which is why they have that image on their car logo. Constellations, on the other hand, are different than clusters, and you should see them pretty often when you look up into the sky. For example, here in the Philippines, many people will be able to spot Orion because you've got his belt, or in the northern hemisphere, people can often find the Big Dipper. And the definition of a constellation is this here. Pause this, write this down, because you can see them together as a group of stars that tends to form an image, but they're not necessarily anywhere near each other. You might think, oh, well, this star in his belt is near this one, but this one actually may just be way farther away, and maybe it's just really bright. And so from your point of view, they appear to look like a constellation. But if some alien on another planet elsewhere in our galaxy were looking at towards Orion, then he may not see them together at all. Now you should have some sort of appreciation for the distance between stars within our own galaxy and the crazy distances if we want to go to another galaxy. And so we can say that just between stars within our galaxy, the average distance is going to be about 3 light years. Our nearest neighbor is Proxima Centauri as a star, and that is about 4.3 light years. But let's say you want to know how far is it to get to another galaxy outside of the Milky Way. That is going to be about anywhere from, on average, of 300,000 light years to maybe 3 million light years. And that's crazy. And so if you want to look at how many times farther is a galaxy away than a star within our galaxy, we are talking about 10 to the 5th or 10 to the 6th times farther. To get from Proxima Centauri, you want to then go to another galaxy, you're going to have about 1 million more time increments on your ship. That could be lengthy. And star motion, you need to understand what they do in an evening and also what happens to the constellations over the course of a year. For just one evening, if you spend the whole time looking at the stars, their motion is very much like the sun, although most people don't realize that. You are going to have the stars that will stay together, and over the course of maybe a 10-hour evening, they're going to trace these arcs across the sky, just like the sun moves across the sky, except they move as a group. And that's because the Earth is rotating. You almost think that if you were sitting on the Earth and it rotated, you would see the images in this room rotate past you, just like that. If you were in the northern hemisphere, then you might see something like this, with them going around the North Star would be the point that doesn't rotate. Some constellations you'll only see during particular seasons of the year, especially those constellations that are along the ecliptic, like the zodiac constellations. And to understand this, I think we should draw a picture. So let's say that here's your sun, and then here's the Earth going around, and let's say it's maybe the month of January. If you look back this way during the day, you're going to see the sun. You don't see any stars. But if you look this way, you might see the constellation at night of Sagittarius during January. And then 6 months later, 7 months, 5 months, I don't know. Let's say it is now July. And now, when you're up at midnight, you've been clubbing, and you come back and you look at the stars, you are going to see maybe something like Gemini. And you might think, oh, what's happened to Sagittarius? Has it been gobbled by a dragon? No, it's still there, except Sagittarius is up in the sky during noon, and you clearly can't see it because there's a big ball of fire in the way. And all of these different zodiac constellations would be more visible during different times of the year.